Let's solve a problem on circular motion. Here the problem says, a stone is tied to the end of a string 80 centimeter long, is whirled in a horizontal circle with a constant speed. So we have a problem of uniform circular motion because the speed is constant. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? So essentially in uniform circular motion, the only possible acceleration is centripetal. So we are supposed to find the magnitude of centripetal acceleration. Let's begin solving this problem. Here the string length is given to me as 80 centimeters. We'll convert it to meters, making it 0.8 meters. The problem also says that the ball or the stone in this case makes 14 revolutions. So we can calculate how much angle it has traversed by calculating the angular displacement. So angular displacement will simply be 14 into 2 pi because every revolution has 2 pi radians traversed in it. So it will come out to be 28 pi, which can be solved into 88 radians. So total angular displacement for the stone is 88 radians. Now total time taken according to the problem is 25 seconds. So the angular velocity can be calculated as theta upon t. Now remember, this is a constant speed motion or uniform circular motion, so I can use this formula to calculate omega. This comes out to be 3.52 radians per second. Now once we know the value of omega and we already know the value of r, the centripetal acceleration can be expressed as omega square r. It's a standard formula that you already know. So if I put the value of omega as 3.52 and r as 0.8, the result comes out to be 9.91 meters per second square. One important point of caution is that you must put all the units properly and in SI. So avoid using centimeters or degrees while solving, while putting the values of length and angles. I hope this problem is very clear to you. Thank you.